Hello friends, in today's question, a bullet of mass m is fired with a velocity 50 millisecond at an angle of theta with the horizontal. At the highest point of trajectory, it collides head-on with a bob of mass 3m suspended by a massless string of length 10 by 3 meter and gets embedded in the bob. After the collision, the string moves through angle of 120 degree. Find the angle of theta, that is the angle of projection, and B, the vertical and horizontal coordinates of the initial position of the bob with respect to the point of firing of the bullet. So let's draw the basic figure. So this is our x coordinate and y coordinate. A bullet is fired, let us suppose, making an angle of theta. With the horizontal and with the velocity u, and this is the bob. Let us call its position as P at the highest point, and this is the height of the bob. This bob is suspended by a string whose length is given as 10 by 3 meter, and the bullet hits the bob. This bob moves by an angle of 120 degree. Suppose this is the final position that is called R, and it is making an angle of 120 degree. So we are supposed to find out this angle theta and x and y coordinate of vertical as well horizontal coordinate. It means we are going to find out h and x, this, and let us suppose this is y. Okay. So here y will equal to h and x will be the half of the range of the, because this is the highest point, so coordinate of x will be the half of the maximum range r. So let us say this is point Q. Therefore, this angle will be our 30 degree. So we can find out our RQ. We can say in triangle, let us call this a point A, AQR, we have sine of theta is equal to QR upon 10 upon 3, and theta is our, sorry, let's not write a theta, let us call it phi, where phi is equal to 30 degree. So we can say our QR is equal to sine of 30 multiplied by 10 by 3. So this gives us QR is equal to 5 by 3. Now at the highest point P, we can find out the velocity of the bullet. You can say at highest point P, velocity of the bullet, there will be only one component, that is a horizontal component. So we can say at this point the velocity will be u cos of theta. This is u cos of theta. So let us use the conservation of momentum at this point P. So according to conservation of momentum at point P, we can say mass of the bullet is capital M, its velocity is u cos of theta, plus mass of the bob is 3m, its velocity is 0, and that will be equal to the bullet gets embedded into the, you can say, the bob. Therefore we get 3m plus m multiplied by v. So from here we can say that our v is equal to mu cos of theta divided by 4m. M and m cancels out, so we get u cos of theta divided by 4. And let us call this question number 1. Now we are going to use the conservation of energy for point P and R. Conservation of energy for P and R, you can say kinetic energy of bullet and bob system at P will be equal to potential energy of bullet bob system at point R. Now we can simply write the formula. You can say we get half 4m v square is equal to 4m and gh, if h is the total height, this is the total height, let us suppose this is small h, so m and m cancels out, so we can say we get half 4 v square we already have from equation 1, so we get u square cos square theta divided by 16 is equal to 4 into 9.8 multiplied by h. H will be the total height. It means it will 10 by 3 plus 5 by 3. From here we can say our cos square theta is equal to 9.8 to 5 into 2 into 16 divided by 50 multiplied by 50. Therefore, we can get theta is approximately equal to 37 degrees. So this is our angle of projection. Angle of projection for the bullet. On the B part, we are supposed to find out horizontal as well as vertical coordinate, and so we can say the horizontal coordinate, that is x, horizontal coordinate which equal to x will be equal to range divided by 2, and we already know the formula for the range, so we can write it here. We get u square sine 2 theta divided by 2g. We already know value of u, that is given 50 into 50 into sine 2 into 37 divided by 2 multiplied by 9.8. So we get the horizontal coordinate x will be equal to 122.6 meters. And next we are going to find out the vertical coordinate. So vertical coordinate, which equal to y, will be given as maximum height at u square sine square theta divided by g. We substitute the value, we get this as 50 into 50 into sine of 37 whole square divided by 9.8. Therefore we get y is equal to 46 meters. So these are the horizontal as well as vertical coordinate. So this is the part B. Okay. And this is the answer for part A. So this completes the question. Thank you.